Hey everybody, learning card number 10. Do I start everyone like this? I bet you I do. Anyway, we're getting into graphing now, and so we're going to talk some rate of change and slope. And actually, that's learning card for rate of change. Also known as slope. So we've been talking about this for 3 or 4 days. Thought we'd get you something so you can remember some stuff. Have a couple of examples, and then may add one extra one on the back, just for good measure. Remember, we defined rate of change, or slope, as the dependent difference over the independent difference. And the reason why we use the word difference is because, remember, difference in math means answer to a subtraction problem. And that's what you do. You subtract the different values. Usually, no, actually almost always, you've got the y on the top, x on the bottom. Sometimes we'll call it the change of y over change of x. And so the important thing here is, at least in terms of linear relationships, which is what we're doing, we'll get fancy later, is that you need to just find two different points, hence the wonderful you pick two. And you just need two different points in time. You're going to find those, find the difference between those, and away you go. The other thing to make sure that you do is that I recommend labeling what you're doing here. So over here, for the first one, given the delivery cost of cost chart on the right, find the rate of change or slope. So for delivery over here, looks like we're probably moving a couch or something. So we want our dependent over independent. And remember, like in this case here, our independent would be distance, dependent is cost. The distance is affecting the cost. The cost is not affecting how much distance you're going. And so you just need to identify two of those moments. It doesn't matter which two that you do. You just need to do two of them. So we're going to put cost on the top and distance on the bottom. So pick two of the points. It can be any two that you want. So we've got 5 to choose from. It doesn't matter what order you put them in. It does not matter if they're next to each other or not. You just need to pick 2. And then what you do need to do is, when you write this out, the moment in time has to be over each other. Because again, remember, we've got our dependent here, and we've got our independent here. Dependent goes on top. Independent goes down here. Let's make those asterisks so they don't get confused with x's. So I put 44 on the top here because that's my dependent cost. That's a cost, hence why I, have that stuff there. And then I've got 6 here on the bottom because that's. And again, notice, and one of my students yesterday, David, came up with this. Why don't we just color them? Hey, there's an idea. So that comes from the same point. And then we're going to subtract off a different moment in time. And in that case, it's going to be 98, which is the cost. That goes on top. And 15, that goes on the bottom. And again, notice we've got that. Same point. And then you just do the math. Pro tip, I don't have a little graphic for this, but lots of times people like to put the larger numbers first, or at least one of the larger numbers first. It's not always going to be a guarantee that everything's going to become positive, but it certainly helps. So we get negative 54 on the top. And again, remember, that's going to be $54 because we're talking about cost. And on the bottom, I have negative 9 miles. And the nice part is if you put the labels in here, you automatically get the context, because if I divide negative 54 by negative 9, I get 6. But if you were to ask, what does this mean? Oh, this slope, this rate of change is $6 per mile for delivery. Done. And that's your answer. So again, 2 moments. Make sure that the moments are lined up over each other in the formula. The mistake people make is they want to write it just like they see. They want to write it just like they're seeing here. This is horizontal, and they want to put it horizontally across here, and you don't do that. Remember, because again, going across, we have dependent on the top, and then independent down here on the bottom. All right, let's check out question number 2. So you're going to do this same exact thing. And again, some people, your teacher may have said put it was y over x. You can do that too. In the Chicago Marathon, Misa had run for 2.7 hours at the 13-mile mark and 4.3 hours at the 20-mile mark. What was her rate of slope and change for the marathon? So again, I know it's not perfect, but we could get a good average in terms of what she's running at. So the same thing here. So you're going to say, okay, I've got y over x. I've got dependent over independent. Now the question is, what's the dependent part? The 2 pieces of information, the 2 moments of time that we've got here, we've got one here, 2.7 hours at the 13-mile mark. And we have another one over here, 4.3 hours at the 20-mile mark. 99.7% of the time, independent's going to be time, unless you're a time traveler, in which case it's a little different. But you're going to put time on the bottom. In this case, we're going to put distance on the top. The longer she runs, the further she's going to go. Remember, independent is the cause. Actually, here, we can put it up here. So the effect goes on the top. The cause goes on the bottom. So again, we've got 2 moments in time. I'm going to put 4.3 first because that's the larger one, because it should be nicer then. So in terms of distance, I've got 4.3 hours and 20 miles. So the distance is 20 miles. The time is 4.3. And again, notice this is 1 point. Then we're going to subtract off the other moment in time. Because again, remember, you only need 2, just like Panera. And the other distance is 13 miles. And she hit that at 2.7 hours. So actually, let's write that out. Miles over hours. And so let's highlight that accordingly. I need my blue. And then just do the math. So it's the setup that tends to cause the most problems with this, not, the actual math. Because I'm going to trust you guys know how to subtract. So I'm going to get 7 miles on the top, and I'm going to get 1.6 hours on the bottom. If we can make it look nice. And then you can divide this out. So you can pull out your calculator. Did you already get your answer? You should have. So 7 divided by 1.6. Wow, I just hit exponential. That's not good. You get 4.375. And again, now notice up here, we've got, here's the beautiful part. There's your label. Wow, you can't see that. Bad move. Apologize. I'll just circle it. 4.375 what? Miles per hour. And now you should really, especially if you're planning on taking any sort of AP classes, you should get into the habit of writing these out. So it's just that, ooh, there's the answer. So Misa rate for the marathon was 4.375 miles per hour. We're going to do something a little different. I want you to flip this over. Pause where you need to, but let's flip this over. I want to do one more example. The one thing we didn't do is graphing. And graphing doesn't really change, and it's going to be just kind of a rough draft. Make yourself a set of axes here. Again, this is on the back of your learning card. Actually, before we do that, do this. We're going to say graph on back. Flip. For graph. All right. Oops, too far. There's your axes. And if you have a graph, yeah, you understand that this is not going to be exact. That's okay. Let's go through the origin. Actually, do this. Make the points first. So let's say we have one here at 2, 1. And let's say we have another point up here at 4, 3. And then, so obviously we'd have to have a line going through there. So, and I understand that your graph is not going to be perfect. That's okay. But if you're trying to find the slope of this line, it's the same exact thing. Remember, the points go this way. It goes x and y. So, slope equals y over x, dependent over independent. And the reason why I write all this stuff out so much is because brain studies have shown if you write it out, it actually sticks in your head better. So if you're trying to memorize this, just seeing it once isn't good enough. Actually, technically, the best way to memorize something or to learn something is to say it while you're writing it. So then the last part again, since it's y over x, pick a point. So I'm going to go 3 is my y value, 4 is my x value. And again, let's go back and highlight these. There's a point, there's a point. And then we're going to subtract it because, again, remember it's dependent and independent difference. And then 2 and 1, 1 is my y value, or my dependent value, and 2 is my x value. And again, you got that. So the points line up. So then I get 2 over 2, so then your slope equals 1. So there's some examples of a bunch of different types. I hope that helps sort some stuff out. Always remember to refer back to this as you need to. And we will see you later.